Let's jump right into this explainer. We're talking about the Chrome DevTools Network tab today. And more specifically, we're going to break down what's known as the 60-second troubleshooting framework. It's a real game changer. So picture this. You're right in the middle of a massive product launch. And suddenly, bam, you get a frantic support ticket. The checkout page isn't loading and users are getting angry. The marketing team is losing it, customer success is blowing up your messages, and literally all you know is that a user clicked a button and nothing happened. That's the reality of modern web apps, right? They aren't just simple pages anymore. They're massive, complex engines running hundreds of background requests. And when one of those invisible requests fails, it usually fails silently for the user. Okay, the clock is ticking. You've got exactly 5 minutes to find the actual root cause before this entire mess gets escalated to senior management. No way do you have time to just blindly clear your cache and hope for the best. And you definitely can't just guess. You need hard evidence, fast. So where do you start? You hit F12 or right-click and hit Inspect, and you head straight to the Network tab.
Right away, you're looking at this high-speed dialogue between the browser and the backend. Honestly, at first glance, it totally looks like the Matrix, doesn't it? Just this massive, cascading waterfall of files and API calls. But if you take a breath and look closely, there's a structure there. Every single conversation the browser is having is logged right here in chronological order. But hey, we're on a 5-minute timer. We literally cannot look at everything. We've got to cut through that noise.
To do that, the framework points us to 5 absolutely crucial columns. First up, status. This is your quick health check. Are we seeing a 200 OK or a big scary 500 error? Next is type, which tells you if you're dealing with a visual asset or raw data, like a fetch request. Then you have the initiator. This one is brilliant because it points you to the exact line of code that triggered the request. Finally, size and time, your ultimate go-to metrics for performance issues. Getting comfortable with just these 5 columns is the whole foundation of this 60-second diagnostic.
Now, here is your first real power move. When you're staring at hundreds of requests, manually scrolling to find a red error is a total waste of time. Instead, jump straight to the filter bar at the top and type status code 500. Boom, you instantly isolate the server errors. Or, even better, try a negative filter. Just type negative status code 200 with a little minus sign in front. That completely hides all the successful stuff, leaving only the broken or blocked requests. You've basically just burned down the haystack to find the needle.
But wait, what if the app isn't crashing? What if the support ticket just says, ugh, it's so slow? Well, if it's a speed issue, you want to look at the Timing tab. This tab breaks down a request's journey literally millisecond by millisecond. Because a request isn't just one single action. It's the browser queuing up, resolving DNS, doing that secure SSL handshake, waiting around for the server, and then finally actually downloading the content. And the absolute most critical metric in that whole timeline? It's TTFB, or time to first byte. This is the definitive measurement for server performance. The documentation makes it super clear. If this metric is over 200 milliseconds, you are definitively looking at a back-end bottleneck. Maybe it's a struggling database, maybe it's a slow server. But honestly, it doesn't matter how amazing and optimized your front-end code is. If the TTFB is high, the app is going to feel sluggish. And knowing that tells you exactly which engineering team needs to get involved. Let's jump right back to our original ticking clock scenario. So we used our filter trick, and we found a 500-level error on an API call. Great. But a generic 500 internal server error doesn't actually give a developer much to work with, right? Well, by clicking on that failed request and checking out the response tab, you can turn a generic failure into a total smoking gun. Instead of just saying, hey, it broke, you look at the raw JSON payload and see exactly what the server complained about. Oh, look at that. Database connection timeout. You just found the exact root cause. Okay, now we actually have to escalate this evidence to the engineering team. And this is where we use the copy as curl trick. Guys, this is widely considered the absolute gold standard for bug reporting. You just right-click the failing request, go down to copy, and pick copy as curl. Doing this captures the exact failed request into one single command line string. It grabs everything, the hidden headers, the user's cookies, and the exact payload data sent when they clicked that checkout button.
Why is that such a game changer? Because running that curl command in your terminal totally removes the browser from the equation. If a front-end developer tries to say, it's probably a weird browser extension or it's just local caching, running this bypasses all of that. If the terminal spits out that exact same 500 database timeout error, you've completely isolated the bug. You can definitively hand it over to the backend team, and it just instantly ends the whole blame game.
So let's put this entire 60-second framework together. User says checkout is broken. You pop open the network tab. You filter for those 500 errors. Instantly, you trap the failing post request to the orders API. You check the response tab, and there's the database timeout. You right-click, copy the request as curl, and you're almost done. Finally, you take that response payload in your copied curl command, and you paste that exact bulletproof evidence directly into the Slack thread for the dev team. And you did it all with minutes to spare. Instead of sending a panicked, hey, the site is down message, you just delivered a surgically precise bug report. The database engineers can now perfectly replicate the exact user environment on their own machines and get straight to fixing it. By understanding how to read a network request, filter out all that noise, and grab precise artifacts like curl commands and TTFB, you're no longer just observing a problem, you are actively diagnosing it. And with this rapid framework under your belt, I gotta ask, what invisible performance bugs and silent API failures are just waiting to be uncovered in your own applications right now?